number 1. You're looking up here. I'm going to call you out. On this one, this is a power to a power. Remember, you multiply. Okay? The first rule, when you're multiplying, you add exponents. When you have a power to a power, you multiply them. And then the last thing we learned is the next sheet, when you're dividing, what do you do with the exponents? You subtract. Okay? So on this one, we have a power to a power. So first of all, what is 2 squared?
4.
4. Okay, so I'm going to write my 4. And notice it's in scientific notation, right? So we're going to go ahead and put it in scientific notation for now. Then I'm going to put my multiplication sign, and then 10 squared squared. What does that mean?
10 to the 4th.
10 to the 4th. That's scientific notation. I know it says standard notation. That probably just means they want you to multiply it out, but we'll just leave it. Yeah, we'll just leave it like that.
Do you have another calculator?
I only have, I think, this one. Wait.
Oh, wait, I think my brother has one.
Hold on. I think I have, this one says batteries are low. You can try this one for now. It says batteries are low. I need this one because I need to show y'all how to do some stuff today. You're welcome. Okay, the next problem. What's the simplified form in standard notation again? So they don't really want scientific notation, but I'm just going to write it in scientific notation for now. So the first thing is I'm going to take this long decimal number and what? Square it. So I have no idea, so I'm just going to type that in. 0.00038 squared. Does it let y'all do it on your calculator?
1.444
e to the negative 7. That means 10 to the negative 7. I'll go ahead and do that. Watch. I'm going to write 1.444 times 10 to the negative 7. That's what your calculator says. Does everybody agree with that? Now, what's this? This is kind of a weird one. We probably won't see one like this on your test. Then we still have times this 10. What's 3 times 2? 6. What do you do when you have this same base that you're multiplying? You would add the exponents, right? So I would get 1.44 times 10 to the negative 1. That one was very weird, I know. We won't have one like that on a test or anything. Okay, let's look at this next one. A little bit of a word problem. It says we have a side of a square. What's the area? How do you find the area of a square? Like length times width, which in this case, you're just squaring that side, right? Because that side is the same as the length as it is the width. So I could just say, I'm going to take this and I'm going to square it. I'm just going to multiply it times itself, and that would give me the area. So what is my next thing I'm going to write? What's the next answer? What's 2 squared? 4. And then what's my exponent for my x? 2 times 2 was 4. And what's my exponent for my y? 3 times 2 is 6. Is that our answer? No. So all I did was I squared everything. I squared it. And that's what I get. Because remember, your rule, your coefficient, your number out front, I just square it. There it is. But when you have exponents, what do you do when it's a power to a power? You multiply them. That's all I did.
Okay.
Now you have the x.
Yes. Now we have 2 things to plug in. An x and a y. Yes.
Where did the 2 come from?
This 2 or this square?
The square.
The square came from, here you go. There's one of them. We're going over these together. And here's your other one. Whenever you're trying to find the area of a square, you take the side of it and you square it. So if I knew that this side of my square was 3, then the area is 9 because it's 3 squared.
So whenever you're doing like area and that stuff, you have to...
Oh, you couldn't even see that.
I was going to say you're
Sorry. There we go. So 3 times 3 would be 9. So you just square it to find the area. So that's what I did here. I took the side length and I squared it, and I get that.
So when it is an area, you just do that.
You just square it. For a square. If it was a rectangle, it would be length times width but they would be different because a rectangle doesn't have the same. But a square, what do you know about all the sides? They're all the same. So that's why you just square it. Square it for a square. You hear that? Okay. Now, then I'm going to plug this in. So I have 4 times -2 to the 4th times 2 to the 6th. So I would just do those on my calculator and figure out what is -2 to the 4th. 16, and it is a positive 16. And what's 2 to the 6th? 64? Okay, and then I would just multiply those 3 numbers. 4 times 16 times 64.
Is 4,000.
That would be the area of that square.
4,096.
4,096. What part? Did you understand why I squared it?
I got confused at the very beginning.
Okay, y'all think, what am I calling this shape? A
Square.
square. So to find the area, what are you going to do to it? Square it. That's what's, okay. But the sides of a square are all the same, always. So you square the side, and that's going to give you the area. So I wrote down my side, this right here, and I put the square. So then I just have to use my rules. Like, what is 2 squared? 4. When I have a power to a power, what do I do with those? I multiply them. That's my rule that I learned. So 2 times 2 is 4. And then this power to a power, 3 times 2 is 6. So now I have that. But then it tells me plug in -2 and 2 for my x and my y. You're going to plug in -2 and 2. So I wrote those. That's -2 to the 4th and then 2 to the 6th. So then I'm going to find those answers. Brought down my 4. What is -2 to the 4th? If you put that in your calculator, it tells you it's 16. What is 2 to the 6th power? 64. And then I just multiply the 3 numbers, and it gives me the whole thing. Let me do number 4 because it's the exact same thing. Okay? They're telling me that I know one of the sides of a square is 3mn squared. How would I find the area of that? I would square it. When it's a square, all you have to do is square the side. So now let me figure that part out. What is 3 squared? 9. And then m to the 2nd power, m squared. But n is going to be to the what? 4. 2 times 2 is 4. Okay? So I did that part. Now what do? We plug in the 2 numbers that they give us for m and n. So I'm going to write down my 9. And instead of m squared, I'm going to write what? 4 squared. And instead of n to the 4th, I'm going to write what? -2 to the 4th. And you put it in parentheses because you're taking that -2 to the 4th power. Okay? So I have 9 times 16 times what? 16. That's right. And it ends up being positive. Anytime you have an even power, it ends up being positive. Every time. It's an even power. So then 9 times 16 times 16, 2,304. That's our answer. And that's all we're going to do on that one. Okay? And y'all aren't turning this one in. We're just big review. Okay, next, I have worksheet 7-4. We're going to look at this because did we finish this on our last class? Yeah. Nope. Today's date is the 22nd. We will finish that in just a little bit then. So let me go over this. Shh. If I'm talking, you shouldn't be. Number 1, it says, which of the following is equivalent? So what I have here is 5 x's up here and 1 down here. So what's 5 minus 1? 4. So I know I have an x to the 4th. Now let's do the y's. What's 2 minus 1/2? If you don't know that, then plug it in your calculator. But it should give you, on your calculator, it may tell you 1.5, or it could tell you 3/2. So all you're doing is subtracting your exponents. We're going to look at fractions as exponents at some point, maybe today. Yeah, so that one's D. Okay, I don't want to do that one. I'm trying to think which one. Let's look at 6, because I haven't taught all this just yet. Then, which one of these is written in simplest form? Can you guess? Which one does not need to be simplified on number 6? It's I. What's wrong with this one? You would need to find 3 to the 5th. What's wrong with this one? Yeah, you would have to do 5 to the 3rd and y to the 3rd, and then figure out what is 5 to the 3rd. What's wrong with this one?
A should be 1.
A to the 0 should be 1 times b, which is just b. And this one's just fine. There's nothing wrong with that. Okay, on this one it was that 3 to the 5th. Let's see. I don't really see any others. All right, take out your worksheet 7-4. I'll just go to that. Yeah, this should be the last thing that you got. Lily, yours is probably up there.
Mine's in Miss Bradley's room underneath my desk.
Y'all don't leave your papers under your desks. So your first problem, I'm going to have, let me look. I'll do 2/4 squared. What does this mean? It means that everything, listen, everything in parentheses is being squared. Just like we said on number 14, that whole thing to the 0 power is 1 because all of it is in the parentheses to the 0 power. So what's this answer? What's 2 squared?
3 to 64.
Do what?
3 to the 64.
Well, what's, oh, you're talking about on yours.
Oh, I'm sorry.
No. So on this one, what's 2 squared? Aston. Shh. 4. What's 4 squared? 16. What is 4 over 16? 1/4. So that's your answer. Does that make sense? That's all you're doing. Now that one is if it's just numbers. But then we're going to start with exponents. Yours you may not be able to reduce. That's fine. You can always type it in your calculator like mine. And I know y'all know how to do this. 4 divided by 16. Math, enter. And it tells me that it's 1/4.
I'm sorry, Miss Bradley.
It's okay. All right. Y'all just don't make me talk over you. I can't stand it. It's a big no-no. Okay. The next one that I want to do, here we go. 2x over 3y. Nope, I already have that one. 3, I have that one. I must have liked all those. I have that one. I'll just do this. 3x squared over 15. All of that is squared. So you're just following your rules. What's 3 squared? 9. What's x squared squared?
X to the 4th.
X to the 4th. Aston, when you don't understand this, I'm going to remind you because you're talking to Logan. What is 15 squared?
225.
225. Now, let's see if we're done. That could be the final answer, but I need to just double check that 9 over 225 doesn't reduce. So if I type that in and press math, enter,
Goes 1 to the 25th.
it does reduce to 1 over 25. So you can put the 1 if you want to, 1 over 25. Yeah, I would put it that way. I would write x to the 4th over 25. This is the same thing. It's saying I have 1x to the 4th, and what am I saying right here? That I have 1x to the 4th. Okay? Either of those answers is fine. Let me do another one that has a negative exponent. If I have 3/2 to the negative 3, what happens on this? What I would do is just put everything to the negative 3, and then we'll switch it around. Here comes some people, I think. So I would put 3 to the negative 3, and then what would I put down here? 2 to the negative 3. Does everybody understand that? I just put everything to that power. What's wrong with that, though?
It's negative.
Yeah, we can't have negative exponents. So we have to flip it to the other side. So I get 2 to the 3rd. I can work that out. And then down here is 3 to the 3rd. Am I done? No. Okay, that's like that problem we did a second ago on the worksheet. We still have to work those out. What is 2 to the 3rd? 8. And what is 3 to the 3rd? 27. And 8 over 27, you can check it. That one. So if you did 8 divided by 27, math enter, and that one does not reduce. So it gives you 8 over 27.
Okay, so if you have like ends or something, and then on the bottom you have ends or something, you have to like.
Oh yeah, I'll do one like that. If we have, I'm trying to make up some like it, and I'll do this one to a negative exponent as well. If I have 3x to the 3rd over 2x raised to the negative 4. Okay, I'm going to go ahead and put everything to the negative 4th power, and then I'll switch around. Okay, so that means I'm going to have 3 to the negative 4th. What's my x going to be to? The negative 12. Does everybody understand the power to the power rule? X to the negative 12, 2 to the negative 4, and then x to the what? X to the negative 4. Any questions on that? Like how I got those exponents? Okay. Yeah, I just, all of them went to the negative 4th, but this one I did 3 times the negative 4, and it's negative 12. Now, everything with a negative exponent must be what? Flipped. So I would write my 2 to the 4th, x to the 4th up here. And what am I going to write in the denominator? 3 to the 4th and x to the 12th. Any questions on that one so far?
You have to do 4 minus 12, right?
Yeah. So you can think of it 2 different ways. I could think, okay, I have 4 x's up here and 12 down here. How many more am I going to have in the bottom? 8. So that's one way to think. I should have 8 in the bottom. But let's say that we don't know that. What is 2 to the 4th real quick? Let's just start with our numbers. What is 2 to the 4th power? 16. 2 times 2 times 2 times 2. What's 3 to the 4th? 81. Okay. Now, what she was saying, what's 4 minus 12? Negative 8. Okay, and you always just, whenever you subtract them, you just write it up there in the numerator. But what are we going to need to do with x to the negative 8?
Right now.
Yeah, you're going to have to put it in the denominator. 16 over 81, and there's my x to the 8th. Another way to look at that, though, what I was saying is, I have 4 x's up here and 12 down here. So 4 of them would cancel out, and I would have 8 left over. Okay, so that's a way to kind of go back and check yourself. Okay, so that's like your number 11. I've done some like 10 and 11. We've done one like 13. We've done number 14. Caden, I'm sorry, I didn't even tell you. We're on that worksheet that I gave y'all. Yeah. Okay. Then I have, do I need to do one like 12, or are y'all good with this? Why don't y'all try them and you can compare answers with somebody, and then we'll turn that in a second. All right, we're going on to roots, and let me ask you this. This will help whenever we have fractions as an exponent. When you think of a plant, where do its roots go? In the bottom, down, under the ground. So when we get to fractions in a minute, we're going to remember that the roots go in the bottom. Okay, we're going to just remember that, and that's going to make everything so much easier. That's all you have to remember is where the roots go. So really quick, though, I want to go over some squares and cubes, and you can always just find these on your calculator. Oops, I forgot the 7. 9, and I'll go down to 10. What's 1 squared?
1,
2 squared?
4,
3 squared?
9,
4 squared?
16,
5 squared?
25,
6 squared?
36,
7 squared, 8 squared, 9, and 10. Okay, what are perfect? Now we're going to do perfect cubes. And you'll see a lot of this stuff in Algebra 2. You do not have to write this out. You can always find these on your calculator. I don't even need to go that. The higher the exponent, the less of these we probably really even need to do. So what's 1 to the third power?
1.
That just means 1 times 1 times 1. Okay, what's 2 to the third power? 8. 3 to the third power? Nope, 3 to the third. 3 times 3 is 9, times 3 again is 27. 4 to the third power?
I almost said 9, okay, so.
64. 5 to the third power? 125. 6 to the third power?
You lost me. Hang on.
I think this one's 743, but I could be wrong.
Oh, wait, hold on.
6 over 3 is 216.
Oh, this one's 347. Maybe. What's 7 to the third power?
7.
343. I got that wrong so many ways. Okay. 8 to the third.
512.
Okay. And we can really quit there. Shh. Yeah, we can quit though. And then I could go on to the 4th power. I could go on and do more to the 5th power and so on. Now, the opposite of squaring something is to take the square root of it. The opposite of cubing something or putting something to the 3rd power is to take the cube root. Oh, our bad weather's not done. This is just a storm, a thunderstorm. Okay, so like in this case, what is the square root of 16? Shh. Y'all listen. What's the square root of 16?
Oh, wait.
4. See how they're opposite? The opposite of squaring something is to square root it. So the square root of 16 is 4. What's the square root of 49?
7. No idea.
7. Yes, question?
Yeah, is there like a button on the calculator?
Yes, and I'll teach that in a second. I just want us to understand what cubing and cube root and square root and squaring means. Okay, y'all do need to pay attention. If you're talking while I'm talking, you might do bad on your test on this. Okay, so what is the cube root of 8? If I look at 8, what's the cube root of it? 2. That means what number did I multiply times itself 3 times to get 8? It was 2. What's the cube root of 27? If I look right here, it's 3. Okay, so a lot of my students will write these on the board and they can kind of go by this. You don't really need it. You can use your calculator today. But let's see where else they're going. All right, so the first thing they do, and I'll show you how to do it on the calculator as well, is they say, what is the cube root of 125? Which I could look at my little chart. We'll do that. The cube root of 125. What is it?
5.
5. But let's say we don't know that, or we don't have this little chart. All right, the cube root of 125, it looks like this. Have y'all ever seen a cube root before? Yeah. Okay, the way you put that in on my kind of calculator is you have to press this math button. Do y'all see the math button right here?
Yes.
When you press it, you can see, and haven't I taught this before in here? Okay, there's the cube root. This one right here on number 5, it can be a 4th root, a 5th root, a 6th root, whatever root you want to make it. But you can use this for a cube root. And I would just type in 125, and it's 5. It's a perfect cube. There's no decimal, right? It's just 5. Okay, does everybody get that?
I got 15.
Did you typed in the cube root of 125, or did you type in the square root?
Oh, shoot.
Oh, you're going to crash the light.
Don't press button.
Oh, you multiplied it times 3 by doing that. Yeah, now if you picked the one below it, then you have to put your number first. Okay? Does everybody understand that? We know how to use the calculator. You may have a different calculator than me. All right, what is the 4th root of 16? How do we find that? The 4th root of 16. So this one, I don't have a 4th root button on my calculator. So I'm going to type in the number 4 because that's what root I'm taking. I press the math button and I go down to number 5.
So 16, you said?
Yeah, so that right there is showing me I'm taking the 4th root of 16 and it's 2. Or if you had written this chart down,
Oh, no.
I don't have a chart for the fourth root, never mind. But you could do a chart for the fourth root.
I did not get that.
You didn't get 2?
16. I'm not going 16.
No, the fourth root of 16 is 2.
Well, now you do it if you're trying to get
Do y'all need some more?
No.
Can y'all handle some of these then on your calculator for the first part?
Yes.
Okay. Okay, this one I have 12a to the 2/3. Now we have a fraction. Let me make sure I press that. Okay. So what I'm gonna do is the a is the only thing that's raised to the 2/3. Can everybody tell that? Yes, because it's not written like this. This, everything is raised to the 2/3. On this one, only the a is. This is not what we're doing. All right, so I'm going to leave my 12 alone. It's going to stay 12. Now, what did I say about the bottom number? The bottom number is going to be your root, okay? Think about trees or plants or whatever. In the bottom is the root, under the ground. So it's going to be the third root. We call it the cube root. But the third root of, and what's left over?
A and 2.
A squared. Yes, the a and the little square. That's what you do when there's a fraction as an exponent, okay? That could be something that's like a basic ACT question that's at the very beginning of the math section. If you don't know those exponents rules, like fraction exponents, then you wouldn't know that. Okay, you just remember the bottom number is the root, and then the other number stays inside there. Okay, let me do another one.
Done after that?
That's it, yeah. 5x to the 1/2, and it's just my x that's raised to the 1/2. So that's going to be my 5.
Wait, I got a question.
Uh-huh.
Why did 12 does have 3?
Because I said I didn't do anything to my 12, so I brought it down. The only thing, there was nothing above my 12. It's a 12. It doesn't go away. It has to stay there. So then I take the third root of a squared. Same thing on this one. Look, my 5. It stays. What's another way to write x to the 1/2? Well, what's my root? What's my bottom number?
2.
2. So it's going to be the square root of x. Do you have to write the 2 on this one? No, because remember, a square root's an understood. You can write it like that, or you can write it like that. You could have put the x to the 1, but do you really need to put x to the 1? It's just x. Okay, anytime it's to the 1/2, it's a square root. If it was to the 1/3, it would be a what? Cube root. If it was to the 1/4, it would be a what? Fourth root. Okay. Let me do another one.
You always just put it in front of your multiplying it?
Yeah, when it's written like that. On this one, I have a to the 5/2. It's just a letter. Okay, if I have, if I have a to the 5/2, then I'm going to write the what root? The square root of a to the 5th. Do y'all understand that? The bottom number is the root. Okay? Did you have to write the 2 in that case? No, but if you did, it's fine. It's another way to write square root. Let's look at 154y all to the 2/3. What does that mean?
Everything.
Everything is going to be taken to the third root. All right? So I'm going to write my third root. And what am I doing with the 54 and the y now? Squaring it, right? Once I get rid of this 3, what's still left? Squaring it. So what is 54 squared? It's going to be a big number. 2,916. And then my y is also squared.
Wait. Oh, wait, no. That was cute. Never mind.
Okay.
What's 64?
I was like, number 6 says 64 cubed, which is 200.
Hold on. Wait. Let me finish this one. Now, one thing you want to check is, can you take the cubed root of that? Shouldn't we check that to make sure it can't be simplified? How do we take the cube root of something? We just put it in our calculator. So I'm going to press math. Here's my cube root. And what was my number? 2,916. So no, it can't be, and I won't simplify it. We can just leave it like that for now. Okay? All right, let's look at
And it's not going evenly. What happens if you don't?
another one like that.
It's not
What about 24C? I already got that one. No. 24C. I do have that one. Not that one. 98D to the 1/2. Let me do this one. 98D to the 1/2. So I'm going to take the, what? What's my root? What's my root? Aston. What's the root?
The root is 1.
No,
Oh,
it's the bottom number. It's 2. It helps when you pay attention to me and not Logan. So then we have of 98D. Okay. Now, one thing that, let's see, 98 divided by 49. What's 98 divided by 49? Anybody know?
Two.
2. So 49 goes into 98. Have we simplified radicals? Didn't we do that a little bit in here? Very little. Or square root.
Oh, okay.
Did we simplify those?
No.
No? I get y'all in my other class mixed up. Well, this is what you should do. You should see that that's 49 times 2. What's the square root of 49? Anybody know?
7.
7.
Yes, sir.
And then you would have the square root of 2D left over. This is probably what y'all will work on when I'm not here, is roots, simplifying roots. What you need to do when you have a big number, I didn't do this one because that's a really big number, and I didn't want it to be too difficult for y'all. But like this, you look at your perfect squares, since we're trying to find the square root, and you want to know if any perfect squares go into that number. Examples of perfect squares are 4 and 9 and 16 and 25. Remember this paper right here? What are all my perfect squares? All these numbers. If any of these numbers go into 98, then you can simplify the radical. That means your root, okay? So in this case, 49 goes into 98 2 times. What's the square root of 49? 7, and then we still have a 2D left. Okay, I'm not expecting you to completely understand that part today. We'll be practicing that a little bit every day. You have to. Like on ACT, this right here, this right here would not even be an answer choice. Okay, that would not be an answer choice. Because basically, if I said,
I have to just divide all those numbers.
yeah, I'll show you how. Like if you left your answer as that, say last year, is that the right answer, or what did you have to write for that answer?
1.5.
You had to write 1/2.
Oh, just kidding.
Yeah, 2/4, and then it would reduce again to 1/2. You had to write 1/2, or did you get points off, right? Probably. You got some points off because you didn't simplify. This is no different. This right here is not simplified because it has a perfect square in it. What I do, and I tell, even Algebra 2, they're still learning this, okay? They're still working on it. That's why I think it's so important for y'all to know it a little bit better at this age. You just see, do any of these numbers go in it? Yes, I divide it. Like if I had the number, let me see. If I had the number 72, the square root of 72, can I reduce that? What would I do? I would see, okay, does 49 go into 72? No. Does 36 go into 72? You just do 72 divided by 49. Doesn't work. 72 divided by 36, what is it? What is 2? So you would say the square root of 72 is, y'all can't see that, 36 times 2. What's the square root of 36? 6. And then I still have my 2 left over. That is actually your simplified version of that. Okay, that's simplified form. That's not simplified. I do not expect you to know and understand that today. That takes a lot of practice.
So like when numbers 6, we don't have to do it to 262,144. We can just leave that.
Let me see if I can help you on that. 64. to the third power. What did you get for 64 to the third power?
296,144.
Could you take the fourth root of that?
292,000.
So it gave you a fourth. It's a perfect.
I don't know.
If you take the fourth root, let me see if we can take the fourth root of that.
292. I didn't mean to say 296.
Oh, that's fine. I didn't even know which one it was. So I'm just going to see. I'm hoping that that's a perfect fourth root. So I'm going to type in my calculator.
So we do like
Oops. I got to do
divided by.
fourth root. First thing you should check is, did I do that right? If it's a perfect root. Math. Yeah, I did. Okay, there it is. The fourth root of 296,144. You got, what did you get?
Well, it's 292, not 200.
Oh, that's what you're saying. 292.
That big number divided by
Fourth root of 292,144. That doesn't work. It's not a perfect.
I got 262. Yeah, that's
Me
what I
too.
got.
But
I
it's still
got
not
262, 144.
It's still not a perfect square though.
Let's
That's for 64 divided by 64.
262,144.
That's like two.
It is not a perfect
Yes.
root. Okay, I'm going to rewrite our number though. 262,144. So what she's saying is 64. Shh, y'all listen. 262,144 divided by 64. But it's still, I bet it could be even a bigger number.
I tried all the big numbers.
Because 64 cubed is that number. Oh my goodness.
4,096. It's, what's, what's the square root of 1,024? 32. 262, 144 divided by 1,024 is 256. Oh wait, but I want fourth root. What's the fourth root?
Yeah, I don't know. You're confusing me right now.
Yeah, I'm lost. I don't know whether to keep it.
No, just keep it on this one. I'm just trying to figure it out. Because I told y'all I'm not going to do those bigger numbers to y'all just yet.
What are you doing?
So you can keep it like that. Now don't forget your variables as well, okay?
It's not 292, guys. It's actually 260.
It is 262,144. I wrote it right here. And it's the fourth root.
536.
Now, can you do the third root of 729? Let's see, I don't know. Yeah, you can do the third root of 729, y'all.
Wait, what'd you say?
You can do the cubed root of 729.
Wait, is the answer number 6
We're
4?
at 729.
A little check mark line thing.
Hold on, let me pause this and I'll look it up and see.
144.
Okay, the last one, it's the opposite of what we've been doing. They say, okay, write the radical expression. That means it's a root. All right, y'all go back to your seats real quick. So if you miss this, then I have to re-explain it. Boys, y'all pay attention up here. It's easy to teach everybody at one time.
I promise I'm paying attention.
No.
Cannot.
Well, just pay. You can go work with them in a second, but just everybody pays attention at one time. It's much easier on me. Okay, if I have the fifth root of b squared, they just want you to write it as an exponent. So I have my variable is what? B. And then where does the 5 go? Since it's the root, where does it go in my fraction? In the bottom. It's the root. It goes in the bottom. So you would put 2 over 5. That's all you're doing on those. B to the 2 over 5. They just want you used to exponents that have fractions are the same thing as a root. That's the whole point of today's lesson. Okay? Here's another one. The cubed root of 27 d to the 5th.
What if it doesn't have a number?
Huh?
What if it doesn't have a number?
Okay, well, that one doesn't have a number.
No, like.
Okay, I'll do it in a second. Let me get to it. Let me just go in order of my examples. So on this one, what is the cubed root of 27, y'all? Do you know that? Mm-mm. It's 3. So the cubed root of 27, I can just simplify that. That's 3. Now, how would I write the cubed root of d to the 5th as an exponent? It would be d to the what? Not 3/5. The root goes in the what? The root goes in the bottom. 5/3. Okay? D to the 5/3. I already took the cubed root of 27. It was just 3. Let me do some more. The third root.
Wait, wouldn't you have that in parentheses up there? Because that's in there too.
Nope, the 3 I already did. Like, I don't need to take the cubed root of that anymore because I already did it. All right, on this one, what's that going to be? It's just a variable, so it's x to the what? 2/3. The root goes in the denominator. Let me do another one. Here we go. 4y to the 5th. That means the 4 is to the 5th power and the y is to the 5th power. And what's that root? It doesn't have a number. What is that root? It's a square root. Okay, remember if it doesn't have the 2, that's always a square root. You can put the 2. So I'm going to have 4, and then what's my top number going to be?
2. I'm sorry, 2.
No, that's my root. The root goes in the bottom. My top number is 5. My root is 2. For my y, what's my top number? 5, and my root is 2. Because see how both of them were raised to the 5th power? So they both have a 5, and then they both have a root of 2.
And you like put the 4 in parentheses and like do 5 and 2 above it.
Wait, what?
Like you have to print the 2, like the 4y in parentheses, and then above parentheses have the 5 2s.
Yeah, you could do like that. She was saying you could do 4y to the 5 halves.
Yeah, could you write like that?
Yeah, I'm thinking that they just probably do it like I did. Let me see what they did to begin with.
Yeah, I didn't do it. I think so, but
Number. Yeah, they did it like I did. Okay, then we have I done one like all of them yet?
yeah, but
I'll just do another one just for some practice. The 4th root of 256 a to the 8th. The 4th root of 256 a to the 8th. Let me see if I can take the 4th root of 256. I can. The 4th root of 256 is 4. So I'm just going to replace that with 4. Now for my a, what's my top number on mine? It's 8. And what's my bottom number? My root is 4. What's 8 over 4? What's 8 divided by 4? 2. It's just 4a squared. See how much I could simplify that? Again, our goal is just to get used to writing roots and used to writing fractions as exponents.
If it can't simplify, you just leave it.
Yeah. Like number 5, you can simplify. Number 9. Why does it say 7895?
because you messed up.
I have no idea what I did. You can simplify number 9. Okay. Number 8, you can actually simplify your exponents. Like what is 4 over 2, right?